Before we get into the examples, let's summarize some of the laws of exponents that we know because they're going to come in handy. If you take like x to the m power times x to the n, what do you get? X to the m plus n. You multiply, here's how you remember it in words. You multiply like bases, you keep the base, and add the exponents to simplify it. Now, if you had x to the m, and then you take that whole thing to the n power, then exponent on the inside, exponent on the outside, yes, you do multiply. You keep the base and multiply the exponents. It also turns out one that comes in handy is this. If you have x times y, to say the whole thing to the m power, then it does turn out that over a product, the exponent will apply to each factor in that product. It works for division as well, but not for addition or multiplication. So x to the y, or I'm sorry, x times y to the m is x to the m power times y to the m power. And so we've kind of at least touched on those already this semester. Here's another one, and it's related to this one right here. What if you have x to the m divided by x to the n? Instead of multiplication, it's division. What do? You keep the base and subtract the bottom exponent from the top exponent to get the new exponent. So x to the m divided by x to the n is x to the m minus n. These are laws of exponents that you learn about in your last class, but it doesn't hurt to review them. Laws of exponents that you should all know. There's others, like what if you had x to the 0 power? Yeah. X to the 0 power is equal to 1. Actually, it works as long as x doesn't equal 0. 0 to the 0 power, believe it or not, it could be 1, but it could be something else. We don't know for sure. It's an indeterminate form. And there's others. What does x to the 1 equal? X. Okay. So those are all ones that may or may not come in handy in this section, but they're good to know. In this example, we're going to, in part A, or all of them actually, we're going to simplify the rational expression. In part A, we have 10yz to the 4th divided by 40y squared z to the 9th. I want you to notice something here. The operation between all the factors in the numerator and denominator, well, I call them factors, so the operation must be multiplication, right? Now, when you multiply two fractions together, you multiply straight across, right? Can't you undo that multiplication? Don't get me wrong, you wouldn't normally simplify this way, but I'm going to show you this just to help you understand the way and why it works. Because it doesn't work with addition. This kind of simplification does not work if you have an addition sign between any two of those numbers in the numerator or denominator. Okay? This only works for multiplication. So you guys know that if you have a over b, some fraction, and a represents a number, b represents a number, and so that's a fraction. If you have a over b times c over d, then you multiply straight across and get what? AC over BD. But the equal sign is a two-way street, right? So what I was just saying symbolically is, oh, you can undo this multiplication in the numerator and denominator and go backwards and rewrite AC over BD as A over B times C over D, right? So, and that idea is going to be key as to understanding why simplifying rational functions works the way it does. In other words, why you can cancel. You guys are used to calling it canceling, right? Why you can reduce or cancel the fractions. The other thing you need to remember is when you divide a number by itself, what do you get? 5 divided by 5 is 1. That's another reason why canceling works. Okay, so check this out. We can separate this, all of these. And again, this is not the work you're going to show. This is just to help you understand it. Then from here on out, I'll show you the kind of work I expect. So you can separate this into the fraction 10 over 40 times y over y squared times z to the 4th over z to the 9th, right? So it's the operation that allows us to do that. If any one of those in the original problem is plus, you can't separate it like that. You separate it using common denominators, which we'll talk about at another time. Okay, so this question's for anybody. 10/40 reduces to what? 1/4. Y over y squared. It's 1 over y. Okay, wait. Since we're going to go into detail in this problem, let's analyze this at least once. The reason why you can reduce y over y squared to 1 over y is because you can further separate this fraction into, y over y times 1 over y, because y squared is y times y. So I further separated this fraction into y over y times, that's supposed to be a y there, 1 over y. Now, why would I want to separate it into y over y? Because what's y divided by y? 1. That's why simplifying works, you guys. Really what you're doing is separating out the factors that are equal to 1. This is supposed to be a big old 1 right here. Again, you would never, this takes too long. You would never do it this way in your homework, but I want you to understand why it works. Okay. And then, so I pulled out a factor of 1 and I realized, oh, that guy's gone, right? So that's why I'm left with 1 over y from this guy. Because one of the y, here's how you're used to doing it. Cancel this guy with one of these guys. 1 over y is left. Okay, if I separated the z to the 4th over z to the 9th, remember, I can think of it as z to the 4th times 1 on top over z to the 4th. Z to the 9th contains a factor of z to the 4th and then 5 others. 5 other factors of z, right? Think about it, just undo that, use that law of exponents. Z to the 4th times z to the 5th. Keep the base, add the exponents, it's z to the 9th. So you can pull out this factor from this guy. You can pull out this factor that's equal to 1. Z to the 4th divided by z to the 4th. That's just a big old 1 as well. And then what's left is this guy. 1 over z to the 5th. Does everybody see that? So this guy is 1 as well. And then what's left when you multiply back straight across, when you get it back to being a single fraction, what's left? 1 over 4y z to the 5th. Do you buy that? Again, that's not the way you're going to do it, right? That'd be ridiculous to do every problem that way. So what is the way you're going to do it? You're going to take the original problem, 10y z to the 4th, over 40 y squared z to the 9th, and you're going to slash a little bit, right? So, okay, 10 over 40 reduces to 1/4, right? And then y, one factor of y here will cancel with one factor of y down there, leaving you with y in the denominator and a 1 in the numerator, but I didn't write it down because I already had one here. And then z to the 4th divided by z to the 9th. Okay, 4 of these will cancel with 4 of those, leaving you with a z to the 5th in the denominator. And then as long as you didn't make anything too messy, hopefully you can see there's just a 1 left in the numerator. And then a 4 times a y times a z to the 5th in the denominator. And yeah, that's a lot quicker, but it doesn't really explain, same thing, but it doesn't really explain why it works the way it does when you pull out a factor equal to 1. So does everybody understand the first way I did it? Okay.